First, I would like to recall, integration by substitution usually integrates a product. One of the functions in the product is a composite function, and the other one is the differential of the inner function. So what are we going to do now? We are going to substitute u instead of g of x. And if u is g of x, du is the derivative of g dx. Now we can go and substitute everything, and we get that this is the integral of fu du. And since f is just a simple function, that it's not composite anymore, we can just go ahead and find the antiderivative. In the case of the definite integral, we do exactly as before, but in addition, we have to translate the limits of the integration to the new variables u. So instead of a, we are going to have g of a, and instead of b, we are going to have g of b. Now I want to start to do more, I would say, sophisticated examples, and many of them are involving the function ln of x. Let's do this example. I see a quotient here, but any quotient can be written as a product, so I'm going to write this as a product. Now I realize easily that I have here a product, and one of these functions is a composite, and it's this one. So now I know that u has to be ln of x. And that's why du is dx over x. And I get this integral. Again, what are the limits of integration? X equals 1, so u is ln of 1, which is 0. When x is e, u equals ln of e, which is 1. The antiderivative of u to the power of 2 is u cubed over 3. And now when I substitute the limits and take the difference, I get 1 over 3. Pay attention, at 0, u to the power of 3 over 3 is 0. Another example. When I see something like this, it is really much more difficult to spot what is the product, and even worse, what is the u substitution. So again, I will start by writing this as a product. When I write it like this, then I have to think, where is the composite function? And I definitely see that this is 1 over ln of x, because this is like ln of x to the power of -1. So the u has to be again ln of x, and d of u is dx over x. And I get the integral of 1 over u du, and the limits of integration now are limits of the u. So when x equals e, we get u equals ln of e, which is 1. And when x equals e to the power of 2, the u is ln of e to the power of 2, which is 2. The antiderivative of 1 over u is ln of u in absolute value. So we get ln of 2 minus ln of 1, which equals ln of 2, because ln of 1 equals 0. Be careful. In the first one that we had, ln to the power of 2x over x dx, it was easy to notice which function is the composite one. But in the second integral that we did, it was less clear. You should be familiar with the combination of ln of x and dx over x. Example. Integral of ln of x over x dx. First of all, I will write it as a product. Well, if I look at those functions, I see a product of two functions, but I see no composition at all. So it's very difficult to spot which one is the u and which one is the du. So that's why you have to be familiar with the combination of the function ln of x and the differential dx over x. So dx over x is the differential of ln of x. And just because of that, you should know that in this case, the u has to be ln of x, and obviously du is dx over x. Now we are okay, we know what to do. It's u to the power of 2 over 2 plus c, and we have now just to go back and substitute the ln of x instead of the u. We are going now to evaluate the integral of ln of x over x times ln of x dx twice. First by the substitution u equals ln of x, and then by the substitution u equals ln of x. So let's start with u equals ln of x. In this case, du is dx over x. It will be easier first to write it like this, because now I see that the first part, ln of x over ln of x, is ln of u over u, and the second part is just d of u. Now I have to do another substitution. We will call it w substitution now, because we are already used the u. So w is ln of u, and dw is du over u. So now I'm getting the integral of w dw, which is w to the power of 2 over 2 plus c. Now we have to go back to the x. So first of all, we will replace w by ln of u, and we get that. But now we have to replace u by ln of x. So it is ln of x to the power of 2 over 2 plus c. Now we are going to do it in a much easier way, but the fact is that when you see this one, you really tempt to do substitution of u equals ln of x, which is okay. Nobody can really realize that it's much easier if you substitute u equals ln of ln of x. So now we are going to do the easy one. So in the easier substitution, u equals ln of x. So it's du, it's dx over x times ln of x. Now you can realize easily that this is just the integral of u du, which is u to the power of 2 over 2 plus c. So now you just replace the u by ln of x, and you get that. Be careful. Let's talk a little bit about integrals that are logarithm. So let's do it by example. Integral of 1 over x minus 3 dx is what? It is the u substitution. Many people are really surprised about that, because they think that because the integral of 1 over x dx is ln of x in absolute value, then every time when they see an integral of 1 over something dx, they think that this is ln of the something, but this is wrong. So let's see. U equals x minus 3. Why do I need a u substitution here? Because this is not just x to the power of negative 1 or 1 over x. This is 1 over a polynomial. Well, it's a linear simple polynomial, but it's not just x, so it is a composite function. When u equals x minus 3, we're lucky to have du equals dx. And we get that. So it is ln of u in absolute value plus c, so it's ln of absolute value of x minus 3 plus c. Let's say that somebody doesn't do a u substitution, is still going to get the right answer. For the wrong reason. Because this was just a special case of a u substitution. Why it was a special case? Because du was equal dx. If you really think that an integral of 1 over anything dx equals ln of this anything, then this is totally wrong. Well, I was just lucky at very few cases it can be right, but it's usually 99.9 wrong. So if you have an integral of 1 over x dx, it is ln of x in absolute value plus c. But if instead of the x you have something else, you really should do your substitution. Example: integral of 1 over 5 minus x dx. So again, we have to use a u substitution. U is 5 minus x, and du is negative dx. So this is negative the integral of 1 over u to u, so it's negative ln of u in absolute value plus c. So we get here negative ln of absolute value of 5 minus x plus c. Let's do another example. It's the integral as before, but now we have limits of integration, and this is the finite integral from negative 7 to 1. Your substitution, obviously. U equals 5 minus x. du equals negative dx. What happened to the limits of the u? When x equals negative 7, we get that u is 5 minus 7, which is 12. And when x equals 1, the u is 5 minus 1, which is 4. Now we are taking the antiderivative of 1 over u, and we get ln of u in absolute value. We have the minus 4 before, and the limits of the integration are 4 and 12. So it's negative of what? Ln of 4 in absolute value minus ln of 12 in absolute value. Yes, but I don't need the absolute value because 4 and 12 are positive. So I get here ln of 12 minus ln of 4, which is ln of 12 over 4, which is just ln of 3.